Okay, I'm on the ion product constant of water. And in the previous section, we saw that water can be an acid or a base, right? And if it is, it's amphiprotic. And since water can act as an acid or a base, if you've got one water molecule next to another, like we have right here, what can happen is a hydrogen can actually be given from one water molecule to another. Okay, and when that happens, I form something called a hydronium ion, which we learned about in the previous section, and a hydroxide. And since this occurs in solution and it forms an equilibrium with its ions, we can write something called an equilibrium constant expression, which we're not so concerned about in this class, but it's relevant because this plays a role in doing pH calculations. So this is kind of an introduction to pH calculations. And Kw is called the water ionization constant, or the ion product constant. And what this means is if I have the hydronium ion concentration in a solution, and I have the hydroxide ion, or the other one, hydroxide ion concentration, when you multiply them together, they equal a constant value depending upon what temperature that we're at. So if I'm at 25 degrees Celsius, it equals 1 times 10 to the negative 14th. So that means if I want to calculate the hydronium or the hydroxide ion concentration of a solution, then I can using this equation. So I will give you this equation on a test or a quiz. You just have to know how to use it. Okay? So let's take a look at the next page. So let's say we are at 25 degrees Celsius and I want to calculate the hydronium and the hydroxide ion concentrations in water. So if you take each one of these and use the variable x in place of their concentrations, that means you would have an x in place of the hydronium and the hydroxide. So this would become an x and this would become an x. What's x times x? X squared. So then you're going to have x squared is equal to 1 times 10 to the negative 14th. So you've got 1 times 10 to the negative 14th equals x squared. And if you take the square root of both sides, you're going to end up getting x is 1 times 10 to the negative 7. And the unit would be molarity because x equals the hydronium ion concentration, and it also equals the hydroxide ion concentration. Okay? If they give you the hydronium or the hydroxide, you could just use that in place of x. Does that make sense? Okay? So I'm going to skip the quick check. And can I go on? You all have that? Okay, so I'm going to skip this quick check. We're going to go past this. And I'm going to come down here to adding acid or base to water. So when you add acid or base to water, that causes a change in the hydronium and the hydroxide ion concentrations. So if you increase the hydronium ion concentration by like adding an acid to water, like let's say we add vinegar, which contains acetic acid, it will cause a decrease in the hydroxide ion concentration and vice versa. So if we're looking at whether a solution is acidic, neutral, or basic, if the hydronium ion concentration is bigger than the hydroxide ion concentration, you have an acidic solution. If those equal each other, it's neutral. If hydronium is less than hydroxide, it's basic. In terms of pH, if your pH is less than 7, it's acidic. If it equals 7, it's neutral. If it's greater than 7, it's basic. Turn to the next page when you're ready. Okay, what we're going to do is we're going to practice some problems. So I'm going to take a look at this sample problem and explain it to you. So here in this sample problem, they want to know what the hydronium and hydroxide ion concentrations are in 0.5 molar HCl. Okay, so HCl is a strong acid. That means HCl will break apart into hydrogen ions and chloride ions. Okay, you learned in a previous section that hydrogen ions are the same thing as hydronium ions. Agreed? Okay, so if they tell us that we have I'm going to put this in a different color, a 0.5 molar HCl solution, can I calculate the hydrogen ion concentration from that? Yeah. Okay, so you look at the coefficient. I have one hydrogen ion. So 1 times 0.5 is what? 0.5. So the hydrogen ion concentration is 0.5. So doesn't that mean that my hydronium ion concentration is also 0.5? Okay, so if that's the case, then couldn't I put 0.5 in place of hydronium in that equation? And I could solve for the hydroxide ion concentration that I need. Okay, so that's what they did. They put 0.5 here for hydronium, and then they just divided both sides by 0.5. So they took this divided by 0.5, this divided by 0.5, so this cancels. Then they figured out the hydroxide ion concentration is what? 2 times 10 to the negative 14. And then if we're trying to justify that this is an acidic solution, the hydronium would have to be greater than the hydroxide. And is it? Hydronium is 0.5. So is 0.5 greater than 2 times 10 to the negative 14? Yeah, so we just justified that this solution is acidic. Okay, now the thing that you want to watch out for is the chemical formulas that I give you. Like here you're given HCl, but if I give you something like H2SO4, let me put this in a different color. If I give you H2SO4, and let's say I tell you this is a 1 molar H2SO4 solution. When that breaks apart into ions, what ions will I form? How many H's? 2. So this would be 2 hydrogens and a sulfate. Okay, so you want to make sure that you pay attention to what ions will form, because here, wouldn't I have a concentration of 2 molarity for the hydrogen ions instead of 1? Do you see the difference? So this is releasing 2 hydrogen ions into solution, whereas this one back here, this HCl, was only releasing 1. So that means when you go to do this problem, the H3O plus concentration is 2 molar, because the hydrogen ion was 2 molar. So when you put it into this equation, hydronium is 2 molar, and then you could go ahead and solve for hydroxide. Does that make sense? Okay. Okay. Let's come down to the practice problems. Let's look at number 1. Okay, so for number 1, it says calculate the hydronium ion concentration and the hydroxide ion concentration in 0.15 molar HClO4. You need to know if HClO4 is strong or weak. Look back in the previous section. You tell me. Strong? Awesome. Okay, so this is a strong acid. So that means that it completely ionizes. So when it breaks apart, can you tell me what ions will form? Yeah, H plus 1 and ClO4 minus 1. So this would be 0.15 molar. That's really the only one that I'm concerned about, because this hydrogen ion concentration is the same thing as the hydronium ion concentration, right? Okay, so now I can write out my equation. So it's 1 times 10 to the negative 14 equals hydronium times hydroxide. So you're going to put this 0.15 here. And then you can solve for hydroxide. So how would I solve for hydroxide? Yeah, divide both sides by 0.15. So this cancels. You're going to end up with 6.67 times 10 to the negative 14. They want us to justify that this is an acidic solution. Well, the concentration of hydrogen ions is 0.15, so isn't that a lot bigger than this number? So since your hydronium is greater than hydroxide, that means this is an acidic solution. I'm assuming you know that the 3 dots mean therefore. Okay. Okay, I'm going to skip number 2. Let's go to number 3. Okay, number 3 says we dissolved 1.42 grams of sodium hydroxide in 250 mils of water. They want us to calculate the hydronium and hydroxide ion concentrations. Okay, so you probably want to think back to the molarity triangle. What do I need to solve for first? Molarity. Before that. Liters. Okay, so this, we can just move the decimal 3 places to the left. And this is 0.25 liters. What else do I need to do? Grams to moles. Okay, we can convert grams to moles by dividing by the molar mass. Okay, so how do I figure out the molar mass of NaOH? Yep, we have to add Na to O and H. Okay, so what is Na on the atomic mass periodic table? Yeah, 22.99 is sodium. Oxygen is 16. Hydrogen is 1.01. Okay, so 22.99 plus 16 plus 1.01. This is 40. So 1.42 divided by 40, I've got 0.0355 moles. I'm not rounding off to anything. I'm just writing out what it gives me. And then you need to divide this by liters so that you can get molarity. So I've got 0.142 molar NaOH, okay? Is NaOH a strong or a weak base? Yeah, it's a strong base. So that means it will completely separate into ions. So if this is 0.142 molarity, what is my hydroxide ion concentration? Same thing, because there's a coefficient of 1 on it. So this is 0.142 molarity. So this is what you will use in the equation when you solve for the hydronium ion concentration. Okay, so you're going to take 1 times 10 to the negative 14 equals hydronium ion times 0.142. So you will divide both sides by 0.142. So this cancels. And you're going to get 7.04 times 10 to the negative 14 for the hydronium, okay? And that's a basic solution because this concentration, or this one for the hydroxide, is a lot bigger than this concentration for the hydronium. So that's how you know it's basic. Okay. Give me 1 second.